Welcome to video 3 for our lecture video series for Friday, March 24th. We just discussed the complete ionic equation as a means of representing what's happening in an aqueous chemical reaction. And now we are going to discuss the concept of a net ionic equation, which is similar to a complete ionic equation in that ions indeed are shown. However, net ionic equations are kind of like a shorthand. So by definition, a net ionic equation is an expression of an aqueous reaction where something called spectator ions are removed from the equation. So what on earth is a spectator ion? Let's think about where you've heard this word spectator before. So let's say that you're at a Giants game, and if you're a spectator at a Giants game, you are not down on the diamond playing ball with the Giants, right? You are not directly involved in the interesting thing that's happening at that Giants game. You're just hanging out. You're there, you're present, you're observing what's going on, but you are not an active participant. So a spectator ion can kind of be thought of as the same way. A spectator ion is simply an ion that was unchanged during the reaction. And I like to think of these as ions that are not involved in the interesting chemical change that occurred. And remember, when we are looking at complete ionic equations and net ionic equations, and even our molecular equations, these are representations of what is happening inside our beaker before and after an aqueous reaction has happened. In particular, this expression of our aqueous reaction, when we're talking about net ionic equations, is simply that. It's an expression. It's kind of like the shorthand condensed version that shows what chemically interesting phenomenon happened as a result of our ion soups being mixed together or our solutions being mixed together. So it's very important to remember that the spectator ions are still present in the solution. They're just not active or non-participatory in the chemical change that was going on in that beaker. So just because the Giants are playing a baseball game doesn't mean that there's nobody around to watch. It just means that there's nobody that's involved that is a non-Giant or non-opposing team member, right? The spectators are present, but when we're talking about the game, we're not thinking about what the spectators are doing. So let's look at our prior example of silver nitrate and ammonium chloride. So we had our balanced molecular equation. This is just our overall regular chemical equation, which was the ammonium chloride reacting with silver nitrate, both in solution, to create ammonium nitrate in solution and silver chloride solid. That was our molecular equation. So our complete ionic equation from that, showing everything that's aqueous in their dissociated ionic forms, this would show the ammonium cation in solution in a 1-to-1 ratio with the chloride anion, mixing with the silver cation present in a 1-to-1 ratio with the nitrate anion to form, we have this aqueous product here, so we need to dissociate it, ammonium cation and nitrate anion in solution, and then finally the silver chloride solid. So let's see if we can't identify our spectator ions. So our spectator ions are ions that are unchanged during reaction. So that means that they appear on the reactant side and on the product side completely the same, right? They just kind of hung out. So if I'm looking at this complete ionic equation, searching for ions that did not undergo any kind of interesting change as a result of this chemical reaction, I see that I start with an ammonium ion in solution and wind up with an ammonium ion in solution. So that is one of our spectator ions. And then we've also got the nitrate ion, which appears the same both pre and post reaction. So the nitrate ion is just hanging out in solution, not undergoing any kind of chemical change. However, we do see that chlorine and silver, those are the ions that, when associated, resulted in the formation of our interesting thing, which is the formation of our precipitate. So if I were to write the net ionic equation, or NIE in my abbreviation here, this would show the overall actual chemical change, which was that silver ion associating with the chloride ion to form insoluble solid silver chloride precipitate. Now, if we were to think about what's going on in the beaker, both pre and post reaction, I would still see the presence of those ammonium and nitrate ions. They're just, again, not responsible or not involved in the chemistry that formed my actual new product, which is my silver chloride solid. So I had ammonium chloride with silver nitrate, and it is the association of silver and nitrate that's going to form our solid silver nitrate, leaving behind in solution ammonium ion and nitrate ion. So before we have this kind of mix of solutions, mix of ions in solution, here we have now an ammonium nitrate solution with now the solid silver chloride precipitate, meaning if I were to filter out this solid, I'd be left with an ammonium nitrate solution and then my silver chloride precipitate. So the net ionic equation, this is what is showing that ion association that resulted in the formation of our solid product. Like I said, it's a shorthand. So as long as you are able to get your complete ionic equation and cancel out any spectator ions or ions that remain in solution unchanged as a result of your chemical reaction, then you'll always be able to get your net ionic equation. Just make sure that for reactions that are not all one-to-one, like this one, like perhaps our reaction where we looked at potassium phosphate and magnesium chloride, that when you look at these, you're ensuring that you've got your correct proportions of everything out in front. So here, if I wanted to write the complete ionic equation, I would need to neglect the presence of my potassium ions. There are 6 on both sides. And then the presence of my chloride ions, there are 6 on both sides, so I would need to show in my net ionic equation 3 magnesium cations associating together with 2 phosphate anions to create our solid insoluble magnesium phosphate product. So take care when you are predicting your precipitate and writing your complete ionic equations, because that is going to be how you obtain your net ionic equation.